All right, 30% of the time some item produced is defective. All right, so during an inspection, select 6 items. Notice this problem does not actually tell us it's a binomial distribution, but our hint is select 6 items. That means we've got 6 trials. This is telling me I've got an n value of 6. And over here, 30% of the time are defective. So I'm wanting to find defectives. So this is actually my probability of success, because here success is being defined as finding a defective. So my probability is 0.3. All right, exactly 2 defectives. That's the probability that x is equal to 2. So that's going to give us 6 choose 2, 0.3 to the second power, 0.7 to the fourth power. Notice it's a little bit different from our binomial theorem, because now our R value is actually going with the p-value. So I'm going to put this in my calculator. So we've got now 6 choose 2 times 0.3 raised to the second times 0.7 raised to the fourth. Okay, so if we're looking for exactly 2 defective out of 6, that means 4 are going to be not defective. That's our other way of remembering where the power goes. All right, 3, 2, 4, 1, 3, 5. And I'm not rounding it because this is an exact value. So I can say exact. All right, at least 2 defective. That means the probability that x is greater than or equal to 2. Well, notice that's the same as 1 minus the probability that x is less than 2. That's the same as 1 minus the probability that x is equal to 1, or that x is equal to 0. So we can never go negative, but here we can keep going with x up to infinity. So there's no way to count starting at 2 going up. So I'm going to calculate this one. This is 1 minus 6 choose 1, 0.3 to the first, 0.7 to the fifth. That is a 5. Minus 6 choose 0. 0.3 to the 0 is just 1, and then 0.7 to the 6th. All right, so 6 choose 1 I know is 6. So I'm going to have 1 minus 6 choose 1 was 6 times 0.3 times 0.7 raised to the 5th, and then minus 6 choose 0 is 1 times 0.3 to the 0, which we're going to ignore, and 0.7 raised to the 6th. All right, 59825, sorry, 579825. 57825. So these I worked out on my own, but we also have some calculator functions that will do it for us. So the calculator function, notice that we've got binom PDF, so this is when it's exactly equal to a number. Binom CDF, the C stands for cumulative there, and this only works for x's less than or equal to. So notice here we had greater than or equal to. Well, here we said less than 2. I also could have said less than or equal to 1. Yeah. So here are the inputs. When we have CDF, we have 0.3. Our x value is 1 because less than or equal to x would be 1. So please type those in your calculators. Confirm that you get the same answers as I got, and you should. All right. And then I'll be back with this last example.